So this is a question from AP Chemistry 2021 paper. This is question 5 over here. Now this is an electrolysis cell over here. And first of all, they say that we need to show the direction of electrons. Now this is molten MgCl2, which means there are two types of ions. First of all, there's the magnesium ion, and then there's the chloride ion over here. Okay, now the chloride ion, since it's an anion, this is attracted to the anode over here. This is the anode, and the magnesium ion is a cation. It's attracted to the cathode over here. Now, chloride ion has one extra electron, and it's going to give up its electron, and this becomes chlorine gas. So we see in this equation over here. Now I've just reversed the equation and I've written it this way because that's how it happens in real life. So chloride ion comes and gives up its electron. This electron goes here, and then it just travels this way and it comes this way. Now it's saying we have to draw the direction. What you could do is you can either draw an arrow like this, or you could point it like this. Now one thing which we need to make sure is that you cannot draw an arrow like this in the electrolytic cell. This is because the ions travel through the wire. This is because the ions leave the anode and they travel through this power source to the cathode. They do not pass through the electrolyte. So that's why I erased this arrow, so you cannot draw this arrow through the electrolyte. It should be either drawn by this, or you can just draw arrows over here. Okay. Now they're asking if 2 volts is going to be sufficient for the entire reaction to occur. Now the cell potential of a cell, it can be calculated from this equation, where it's the cell potential of the reduction equation minus the cell potential of the oxidation half reaction. Okay, so the cell potential of the reaction involving magnesium and the reaction involving chloride ions are both given over here. Now we need to figure out what is E reduction and what is E oxidation. So oxidation, this is a common definition, it means loss of electrons. Okay, and reduction is basically gain of electrons. Now as we see over here, chloride ions came, they gave up their electrons. Chloride ion came over here and they gave up their electrons. So this is where oxidation happened. So oxidation happened at the anode and reduction happened at the cathode. So the cell potential of cathode involving magnesium is negative 2.7. Now I'm going to write the equation this way. E reduction, that is negative 2.37. I'm going to subtract positive 1.36. This is how I write it. And then my answer comes out to be 3.73 volts. Okay. Now if I'm checking, if I look at the magnitude, so 3.73, it's much larger than 2 volts, which is why 2 volts are not going to be sufficient for this reaction to occur. Now where we have been given the current supplied, and we have to we have to collect 2 grams of magnesium. So if we look at these equations up above, 2 electrons are needed to make 1 atom of magnesium following this half reaction. Or if we translate it into moles, this turns out to be that 2 moles of electrons are needed to make 1 mole of magnesium. Okay, now we need to know how much does 1 mole of magnesium carry. So here I have the examination paper, and if we look at the first page, which has the periodic table, so we see that the atomic mass of magnesium is 24.3 grams, which basically means that 1 mole of magnesium has or weighs 24.3 grams. Okay, now what I'm just trying to do over here is I just rewrote that for clarity purposes. Now I'm trying to find that 2 grams of magnesium, how many moles do they contain? Since 1 mole of magnesium contains 24.3 grams, now I'm just going to multiply this by 2 grams. So this way these 2 grams are cancelled and we get 0.08 moles of magnesium. So this contains 0.08 moles of magnesium. Now moving on, I want to see how many electrons are required for 0.082 moles of magnesium. Now going back up, we saw in this half reaction equation that 1 mole of magnesium requires 2 electrons. Okay, so I'm just going to rewrite this. 2 moles of electrons require 1 mole of magnesium. So this mole magnesium and mole magnesium, they get cancelled out in this way. And then you can just multiply these two together, 0.08 into 2. So 0.165 moles of electrons are needed. Now, Now this is Faraday's constant. So 96,485 coulombs is the charge carried by 1 mole of electrons. Now I'm just going to find out how much charge is carried by 0.165 moles of electrons. Now why am I doing this is because charge and current are related, as you can see over here. So ampere is equals to coulomb divided by the time. So current, it's basically charge over time. So I'll just try to see what is the charge these electrons carry. Okay, and then I'll just divide this by 5 coulombs per second to get the total time. So let me just do that. So since 96,485 coulombs are carried by 1 mole of electrons, so 0.165 moles of electrons carry lesser charge. And then they carry 15,882, which is a fraction of this number over here. Now let's see how much time would how many more seconds would I take for this large amount of charge to flow, because 5 coulombs of charge flow in 1 second, because that's the current over here. It says 5 amperes. So 5 coulombs, so ampere is basically coulomb over second, so 5 coulombs flow in 1 second. So how much more seconds would 15,000 coulombs potentially take? So I just divide this by 5 and I get my answer as around 3,176.5, and this was my answer for part C. Now when I was looking at examiner reports for this particular exam, this question was not so well attempted and the average score was a bit low, so that's what I'm trying to do on this channel. I'll just try to teach the most difficult topics first and then move on to the easier ones. Hopefully you enjoy this video, and if you have more comments, questions, more video requests, please do shoot me an email. I would be happy to take a look at them. Thank you.